Hello, so today I'm looking at M3 International A-Level, May 2015. This is question 6. So here I have the shaded region R is bounded by part of the curve with the equation y equals x squared plus 3, the x-axis, the y-axis, and the line with equation x equals 2, as shown in this figure. The unit of length on each axis is 1 centimetre. The region R is then rotated 2 pi radians about the x-axis to form a uniform solid S. So using algebraic integration, first of all I need to show that the volume is this expression, and this is for 4 marks. So to do the volume of revolution, I know that the volume is equal to pi y squared dx. So here I'm doing pi, I'm integrating from 0 to 2. This expression squared, so I would have x squared plus 3 multiplied by x squared plus 3, and so that will give me x to the power of 4 plus 3x squared plus another 3x squared, so altogether 6x squared plus 3 times 3, which is 9. And I'm integrating with respect to x, so that gives me pi. Okay, here adding 1 to the power, dividing by new power, add 1 to the power, divide by new power, so 6 divided by 3 will give me 2, and here this is really x to the 0 here, add 1 to the power would give me x to the 1, divided by 1, and that will be evaluated from 0 to 2. When I pop 0 in here, I'm going to get 0, so I'm only really concerned with what happens when I put 2 into all of this. So I'm going to do pi times by 2 to the 5 is 32 over 5 plus, here I get basically 2 to the 4, here I get 9 times 2, and then I can pop all of that on my calculator. Or if you don't trust your mental calculations, just stick a 2 into all of this. On your calculator, quite a useful thing can be, if I pop 2 into the memory, okay, I've popped that into memory A, and then I can just type in what this says, but with A's. So A to the power of 5 divided by, whoops, start again, A to the power of 5 divided by 5 plus 2 times A cubed plus 9A. And so I get this 202 over 5 multiplied by pi. Okay, so first of all I'm going to check that that's what they got. Phew, 202 over 5 pi cubic centimetres, so I'll just pop the measurements on there as well as required. So that is the first part of the question, worth 4 marks. Now in part B, they were asking me to show that to 2 decimal places. The centre of mass of S is 1.30 from O. Right, what was S again? R was this region, but S is the solid formed when you rotate that region 2 pi radians around the x-axis. So here I need to use the formula for the volume that I've worked out here. So the formula that you should be using is pi y squared x dx equals pi integral y squared dx multiplied by y bar. Now this thing here though is what I just worked out here, the volume of revolution. So on the right hand side I can just pop this thing, which was 202 over 5 pi y bar. On the left hand side I need to do a little bit of work. I can actually be a little bit lazy because I'm doing practically the same integral as what I did before, except I need to multiply everything by x. So if I just look at what I did there, I need to now integrate this multiplied by x. So I will have pi. So instead of x to the 4, I get x to the 5. Instead of 6x squared, I get 6x cubed. And instead of 9, I get 9x. And that's still integrated with respect to x, and the limits are still from 0 to 2. So now I can divide both sides by pi and do the integration on the left hand side. So here I end up with add 1 to the power, divide by new power. Add 1 to the power, divide by new power. So I will end up with 6 over 4, which will simplify to 3 over 2. And here I end up with 9x add 1 to the power, so it becomes squared divided by the new power, to be evaluated from 0 to 2. Remembering when I put 0 in there, all of that will disappear, so really I just need to consider a 2 being put in all of those. So here I end up with 202 over 5 y bar. Okay, so I end up with 2 to the power of 6 divided by 6 plus 3 over, oh sorry, it's all gone in as the power, right, 2 to the power of 6 divided by 6 plus 3 over 2 times 2 to the power of 4 plus 9 over 2 times 2 squared. Okay, so popping all of that into my calculator, I get 158 over 3. To end up with y bar, I then need to multiply both sides by 5, divide both sides by 202, and so I'll see what that gives me. So I end up with the answer that I had multiplied by 5 over 202, and that simplifies to 395 over 303. Now, in this part of the question, they said show that to 2 decimal places it comes to this. So if I pop that as a decimal, well, fortunately it's coming out as the right number. So I need to say that this is 1.303 whatever, which is 1.30 to 2 decimal places. So to show that it rounds to 2 decimal places, 1.30 to 2 decimal places, I need to show that this next figure, the figure in the 3rd decimal position, will cause this to stay as a 0 and not change to something else. Okay, so that is part B. Then they give me this very interesting figure here. Okay, so it says a uniform right circular solid cone of base radius 7, so that's here, and height 6, so that's there, is joined to my solid S to form a solid T. The base of the cone coincides with the larger plane face of S, so in other words this big flat bit here, as shown in figure 5. The vertex of the cone is V, so that's here. The mass per unit volume of S, so that is this thing, is twice the mass per unit volume of the cone. Find the distance from V to the centre of mass of T, so the centre of mass of the whole thing. So here I need to do a table to help me do this part of the question. So basically I've got this thing is S, this thing is V, and they're combined to give me T. So first of all I need to look at what the ratio of the masses is. So what is the volume of S? Well, that's what we had in part A of the question. So there I can just copy what they did. 202 over 5 pi. Then I need the volume of V, and the volume of a cone, the formula is a third pi r squared h. So I have 1/3 times pi times the radius squared, so 7 squared, times the height, which is 6. Okay, so here I can see the 3 and the 6 will cancel and give me a 2. And then t is going to be these two things added up. But I need to take into consideration this sentence that they said here. The mass per unit volume of S is twice the mass per unit volume of the cone. So this one here needs to be doubled to take account of that, because it's like every cubic centimetre of this is worth double every cubic centimetre of this. So that's why I need this 2 here. Now, here I can just do this plus this, but because this is the ratio of the masses, you can simplify at this stage. And then you can just add your 2 simplified values to give you the ratio for t. Do be careful at this stage, because a mistake at this line will make everything after this completely wrong. So do be very careful, but I can see I've got pi and pi, so I could divide them both by pi. I can see I've got a 2 and a 2, so I could divide them both by 2. And so in fact I end up with 202 over 5 here, just the 49, and so here I'm going to have these two values added. So 202 over 5 plus 49 gives me 447 over 5. Okay, and that is the ratio of the masses. Now I need to write down the distance from V to the centre of mass. So distance from V, and I'll just measure all of my distances from V in the first place. I might need to do a little bit of fiddling, but when I've actually finished the maths, then I don't need to do any fiddling at the end. So where is the centre of mass of S? Well, from V it's going to be 6 plus the value. I need to be a bit careful, because this 1.3 that I got was from there to there, whereas actually I want this value here. So if here this was the 1.3, then the bit that I need to add on is 2 minus 1.3. So I need 6 plus 2 minus that 1.3, and to be accurate then I'll use the fraction value here. So I need to take away 395 over 303. Okay, so that gives me the distance of the centre of mass of S from V, and I'll tidy that up in a minute. Okay, so 6 plus 2 minus 395 over 303. And so that gives me 2029 over 303. And so now I've got a completely accurate value for this. Instead, the centre of mass of the cone from V, well, here I have a formula that I can use from the formula book. And that formula is h over 4 from here. So from V, I'm going to need to do 6 minus that height, 6 over 4. And so that gives me 9 over 2. And finally, the centre of mass, the distance from V, will be whatever we like, x bar. Okay, so now I'm ready to use these values. So I'm doing this times this plus this times this equals this times this. So I've got 202 over 5 times 2029 over 303 plus 49 times 9 over 2 equals 447 over 5 times by x bar. So I can just stuff all of this in my calculator. So I've got 202 over 5 multiplied by 2029 over 303 plus 49 times 9 over 2, and that gives me this value, which will then be multiplied by 5 and divided by 447. And so I end up with x bar is 5. I've got 49, so I'll round that to 5.5, and everything was in centimetres. They wanted everything to 2 decimal places before, so actually let's try 2 decimal places so that everything is consistent. So that would be 5.49 centimetres in this case. So I'll just have a look at my picture and see if that seems to make sense. So where would I expect the centre of mass to be? Well, this was about 40, that was about 49, so actually this is heavier than this, so I would expect the centre of mass to be a bit more to the right than to the left, even when you've considered the kind of extra mass per unit volume that this had. So I would expect it to be more to the right of the where these two meet than to the left. So in fact 5.49 does seem reasonable, because I'm just expecting something a bit less than 6. Okay, so that part of the question was worth 5 marks. And now I'm going to try the last bit. So, last bit. Point A lies on the circumference of the base of the cone. So here's the cone, so it's somewhere on this circumference. The solid T, so that was the whole thing, is suspended from this point on the cone and hangs freely in equilibrium. Find the size of the angle between VA, so V and this point on the circumference, and the vertical. So here I can just draw a little picture to help myself. So if I have, this is where S and V meet, then so you have this kind of shape. The centre of mass was there. And if I take this point on the circumference to be A, here's VA, and so the vertical is going to be from the point of suspension to the centre of mass. So this is the vertical. Now I know this is the radius of the cone, so I know that that is 7. In order to work out the angle between VA and the vertical, just let me check, is that what they wanted? The angle between VA and the vertical. VA and the vertical, so they want this angle here. So I know that this total length is 6, and I know that the answer that I just got on part C was this 5 point whatever, and so it would be helpful for me to get this length here, and this length will be 6 minus the whatever it was, 5.49 that I got in the previous part of the question. So if I work out, let's call that phi, and let's call the whole thing alpha. So I know that alpha is inverse tan of the opposite over the adjacent. I know that phi is inverse tan of this over the adjacent, and therefore I know that theta is alpha minus that angle that I just worked out there. Okay, so and how do they want the angle? Oh, it just says work out size of the angle, so let's pop these into my calculator then. So I've got inverse tan of 6 over 7 minus inverse tan of 6 minus 5.49 divided by 7. And so I get this angle of 36.4 degrees, so I'll just round that to the nearest degree, so 36 degrees. Okay, so that part of the question was worth 3 marks, and that finally is the end of the question. So I hope you found that solution helpful. Good luck with your studies.